Thank you all for joining me here. Welcome to the first of the new era of the Perl Conference in Europe. My presentation today is called "It's in the Bag." The subtitle is kind of cheeky: "How to Cheat at Interviews with Perl 6." But actually, I have some clarification. Okay, sorry. Some clarification to say. So, yeah, that's clearly clickbait. I couldn't resist the clickbaity subtitle with cheat. But this presentation actually doesn't have anything to do with cheating per se, unless you want to make the argument that coming to an interview armed and equipped with such a full-featured language is unfair. You could say that, probably. And this presentation also doesn't have all that much to do with interviewing beyond the truism that the more you know, the better chances you will have. But yeah, sorry for going for the clickbait. So anyway, the new subtitle that we will use for this talk is How to Win at Interviews with Rakudo. And so the reason why I'm amending it to Rakudo, I've noticed I'm actually the only one so far that has been doing this, but Zofix, one of the core developers of Perl 6, recently wrote a pretty compelling essay in support of changing the name to an official language name of Rakudo Perl 6, but in everyday practice saying Rakudo. I actually have no idea to what extent this has buy-in from other core developers or whether it'll ever catch on, but I'm kind of signaling my support for the name change. So I'll be saying Rakudo instead of Perl 6. Either that will be a glaring sort of anachronism in the future, or it'll be a sign of coming changes. And just one last point on that, I never really got what the big fuss is with calling it Perl 6. Frankly, I still don't, but I also don't care that much. So when a beloved Perl 5 core hacker and colleague recently chided me for being a nut job for wasting my time learning Perl 6, while also admitting that his only real objection to the language comes not from design or implementation, but from the name, I just, whatever, let's give up. Like, if you know, whatever makes the most amount of people the most happy while positioning the language for a vibrant future and hopefully wide adoption, that's what I'm supporting. So, you know, let's call it Rakudo. So about me, my name is John Haltiwanger. The Perl community people who do know me as Abstract. I've been more or less an invisible Perl hacker since 1997, though that's starting to change a little bit with my involvement in Perl 6. Well, Rakudo, sorry. That'll be a funny one. Okay, so currently I'm coding Perl as a senior developer at Booking.com in the product security team. Lots of exciting moments. And if you've ever wondered what it would feel like to deal with pushing the boundaries of scale, I think you would have a lot of fun working with us. So, the TLDR, how to win at interviews with Rakudo. Apply to Booking.com. Get me as your interviewer, use Rakudo. You know where this is going. Okay, so yeah, as you can see, I could never pass up an opportunity to take risks for a good joke. Here I am risking my job in order to reference a /error internet meme. You're welcome. Yeah, it's true. I'm just kidding, of course. I'm pretty sure my job is safe. Oh yeah, I'm also kidding about this. You're not going to get hired just as a result of these steps. Sorry. But to be more precise, it's how you handle step number 4. That everything really resides on that. So I hope to give you some helpful advice on that topic today, but it's actually not necessarily advice that is specific to Rakudo. If you take the time to explore the expressivity and internals of any language that you bring into an interview with me or with anyone else, I'm sure you'll do fine. So the next more accurate TLDR. So the rich core and bootstrapping internals of Recruito provide a potentially perfect storm for satisfying the expectations of some interviewers. Yeah, so while having bootstrapping internals certainly adds to Recruito's implementation complexity, it considerably increases the average developer's ability to poke at what is going on underneath the hood. And while having a rich core, here maybe like what I consider like a rich core would be you have an abundance of operators, plenty of utility types, and at least 4 programming paradigms. No, doesn't, but you know, the more the better, in my opinion. So yeah, that it certainly adds to the cognitive complexity, certainly of learning it and reading it while you're still learning it, but it considerably increases expressivity. So by enabling practitioners to give concise solutions and in-depth explanations of internal underpinnings, these two dynamics combine to create a potentially great choice for impressing anyone with an open mind and a love of programming. So this is kind of the I didn't have time to find a really good resource on this, but I'm sure there's been plenty that's been written. I know Larry did some talks a long time ago on manipulexity and these kind of axes of language design choices, and specifically the ones that Perl the trade-offs that Perl had chosen. But these can all sort of like, everybody loves a good, everything should be readable. So let's just get rid of expressivity. Everything should be simple, so let's get rid of complexity. Everything should be easy, so let's get rid of difficulty. Everything should be worthy, so let's get rid of wastefulness. So these things can at first glance seem to be kind of straightforward dichotomies, but in this case and in just about every other case in the world, further inspection will reveal hidden nuances. So language design trade-offs in any one of these axes will have serious implications on all the other dynamics. So let's talk about a simplistic language just with a handful of operators, so 5 total operators, may reduce the difficulty of learning the syntax of the language. However, it'll inevitably incur readability costs by pushing commonplace solutions into user-defined code, either in a local solution or one found among potentially many available in the language ecosystem. So you can certainly argue that this drives up the complexity of individual source solutions, which in turn actually raises the difficulty of learning the language as it is practically used. This is not only a problem for such a minimalist language as our theoretical 5-operator language, even an operator-rich design. So on the complete other end of the complexity axis, like Perl 5, can end up requiring external solutions for common usage because of other gaps in the design and implementation. So just about all the languages have accepted there will be some everyday problems that require a relatively cumbersome process to resolve. This means we see common patterns everywhere as spiteful bits of boilerplate all over your source code. In a good case, it will be abstracted away into commonly used and or universally distributed, a single commonly used and or universally distributed solution. In a so-so case, the pattern will be simple enough to be replicated inline, in full, everywhere it is needed. And in the worst, or perhaps simply long enough case, it will be abstracted away into many commonly used solutions. See object models, Perl 5. But yeah, even when you're missing some stuff, when a language has paid design and implementation costs to enhance expressivity, you can at least offer smaller amounts of boilerplate. So this is a very common pattern. I'm sure all the Perl 5 hackers have seen this plenty of times. We're creating a lookup, right?
Yeah, syntax
Yeah.
Uh-oh.
That's
should be a percent.
well, is it Perl 5?
This is Perl 5.
Oh,
Then
the one above
I
should be dollar.
Wait, what?
Except the
On line 3, it says dollar lookup.
Yeah, you're right. That's what I get for mixing the two to my mind so much. Yes, and of course it's a screenshot, so it'll take time to replace. Okay, for languages that have paid, like, so here we have the postfix 4 working in our favor, and we have autoviv as well. So yeah, that's just two examples of how two underlying design implementations have, like, we don't have sets in Pro 5, but in practice, it hasn't been that much of a problem. Now here we're moving on to Pro 6. So here we create a set and then we stuff it into this hash. So this is not actually a set anymore. It's a hash with the keys from the values and keys from set. I did that because it's actually technically a little bit faster to do this than to use the set directly. Like, I'll get to some time runs in a second. So yeah, every rule needs an exception to prove it, and the long development cycle of Rapido Perl 6 has finally delivered to us a language in which everyday solutions are either available within the core language or trivial to compose with the mechanisms that the core language provides us. So of course, this isn't going to impress anybody who's used a language with sets in it. But the truth is, it's also not really going to impress Pro 5 programmers because we have auto-vivifying hashes. We know, like, as you could, like the last example showed, it's really, one extra line, and that's the fact that you have to declare the hash before you start assigning keys into it. So it's doesn't mean that sets aren't nice to have around, but we haven't actually. It hasn't caused that many problems in Pro 5. So this implementation is slightly faster than this implementation, where we're using the actual set, which is again a tad bit faster than this implementation. Oh, something didn't get a screenshot. So this implementation here is probably when you're using a set. This is actually the cleanest implementation. So this is probably, in the sense that it's using a set operator. You don't have to, this is already a routine that returns bool, so you don't have to worry about the find or false kind of scenario. However, yeah, so this is the one I would, if someone were going to ask this would be my first interview sort of solution. To me, it's fully self-documenting because you don't have to know about autoviv. It's all right there. It's a single expression on a single container. Yeah. Anyway, don't need to beat a dead horse. So of course, so here's the time runs. The hash key version had about 1 second. The set key had about 1.1, and the container had about 1.25. That's a million hash lookups. I don't know. We're in Amsterdam, but that's a lot of hash, guys. Like, okay. So here's another version though. When we want to, in an interview, you can kind of we can start off and say, hey, look, we have this one, but in terms of code readability, this is what I would choose. But if it's in a hot loop and we really need some performance, we can pull out our immutable data structure, the map. This was actually left over from I was using an enum before, but it's still relevant. So basically, if our value is in the map, calling bool on the result will for sure be true because 0 is the number that's false in Perl 6. Well, in Perl and many other languages. So this would also work. And if even more points, if you can identify an even additional speed up. So here we're removing the boolification. So this is actually if we have a situation where this whitelist is actually could short circuit an operation. So when we get to number 10 of our 1 million lookups, we already know that we don't need to do the rest. Well, that's going to be true for anything. Anyway, sorry. So note that you're going to pay the boolefication cost once this goes into an if condition anyway. So it's not necessarily going to speed things up unless you have a specific situation where you can afford to defer the boolefication and it actually gains you some performance. So, but you can see it's not insignificant. So, but this is where step 4 comes in, right? This is the part of the interview that can get really interesting when people are using high-level features of a language. So, can you tell me how this actually works? If I didn't know Rakudo and I was shown this solution in an interview, one of my follow-up questions would be immediately, so how do you think sets are implemented here? I would be explicit that I'm not asking for the precise implementation details of this mysterious Rakudo thing that you're showing me, but rather the data structure that would be best suited for this whitelist checking task in the absence of a dedicated set type. But since I do know about Rakudo, I'd probably be asking you whether you were aware of the performance implications of sets versus hashes and maps. Either way, it's going to involve you re-implementing the check whitelist solution. So there you go. The changes required to the Rakudo implementation don't even change the line count. What we're doing here is we're taking a list, the whitelist, and we're crossing it. This is such a cool feature. The cross meta operator times tied with the pair infix. So this is a constructor. It's a special constructor because it's infix. So it actually takes one element of this, crosses it with true, takes the next element, crosses it with true, but puts this in the middle, and we get a list of pairs, which we then stash in a hash. Et voila, a lookup. So there you go. No problem. What I wouldn't do in an interview is this is actually kind of this is clever. It doesn't need to be written this way. We could push this stateful. This is an anonymous state variable. So rule number 1, generic interview advice: don't name things. Could help. So we'll get to that in a little bit, but
it depends on if you want to have the job or
not. Right, yeah, that's a good point as well. Yeah, so
don't make your interviewer feel stupid.
Yeah.
Is that somewhat to the $?
Yes, exactly.
Okay.
So you can get an anonymous state variable of any of the 3 core data structures just by leaving the name off. And so this says
anonymous state subroutine too, but I don't know what it means.
Oh wow, I'll have to try that. So this basically says the first time we're in this routine, check we're going to end up falling into this, but every other time this state variable is already going to be declared, so we can just do the lookup directly. Yeah. So this is a pretty clever solution, but I'd say it's pretty ill-suited for anything but a REPL run, a proof of concept, or a personal script. This kind of rapid composability does make the Rakudo REPL extremely powerful, but it is likely to be equally powerful at pushing people's eyes back into their skull while remembering all the Perl is line noise warnings. So this is the approach I would take. I would use a role. This is also enabled by the rich core that Rakudo provides us. So we can deliver this highly composable solution with, look, it's trivial. It's almost, we changed this was a my before, and now it's a has, and it's a object level variable. So yeah, basically the one problem we have here is that lookup is not going to be updated when self is updated. I don't know if we have an easy way for roles to determine whether object state has changed, but I could probably do some kind of wrapping of the um, assign pause or something. Anyway, that's for a different state. Like we're just going to assume that you have a constant lookup and you're not planning to change it. So now you can compose it in a role. So here already you have this immediately available. Any questions? Okay. So and this is another thing. The test module is right there in the standard in the core of the library. So you can just pull it up, do these immediate sort of tests, easy peasy. So another attempt that a newbie Rakudo developer might make, and this is an unfortunate mistake, and I kind of wonder whether we should override contains with something like that. But anyway, on a list, when you use contains, it actually does a stringification. So this test case actually is true. So it's a successful test.
But for the wrong reason.
For the wrong reasons. This is not what you want in your solution. So just something to keep in mind. Every language. There's many things built in, but we don't actually have a direct hash look up whether this variable is present in this list. Value, sorry. So back to sort of how did I end up hacking Rakudo core anyway, and also just this is sort of where my road with Perl 6 picked up, having kind of been waiting for a long time. Let's just say I was following the development of Perl 6 through many phases of its life cycle, but I finally had a use case for it, and that was golfing interview questions. So I would get into interviews with candidates with backgrounds in C++ or Java, and I started to really appreciate all the beautiful things that Perl contains on a day-to-day basis that make my life just so much easier. So whenever I was coding Perl 5 solutions to these interview questions, I couldn't help but wonder, though, what kind of solutions would I be crafting in Rakudo with its promise of being Perl 5 done right? And as an aside, interviewees who use Python or other dynamic languages would be using some features that I could see provided real benefits for Perl over Perl's defaults, sets being one example. So that was another thing, is kind of like, okay, so what would it be like? This Python programmer is using that. That's pretty cool. Oh, Perl 6 has it. So this is hopefully a deprecated interview question. It will be now, I assume. So given string A, determine whether it is an anagram of another string, B. With a follow-up, given string A, determine whether it is a partial anagram of another string, B. So, and almost immediately, a naive implementation, the first thing that people will do is reach for sets and set operators, if their language supports it. And at that point, we can say, hey, that's actually not correct. Because what you're doing when you're using sets here, and these are loose. We're not doing strict anagrams here. So when you're doing sets, you're ignoring all the duplicate or repeating characters. So it'll return true in cases that are actually false. So again, in Perl 6, our solution is just unbelievably simple. Like, we can change from that behavior to this other successful behavior with changing literally the two occurrences of one word. And now this test passes.
That's what bags are for.
They're also really, really handy. I was slicing and dicing groups of DB objects in the Perl 6 REPL, Perl 5 DB objects in the Perl 6 REPL, and assembling lists, classifying things, and I mean it's amazing. Building histograms.
Yeah, any kind of
Yeah. So originally, Rakudo used to have a separate set of baggy operators, which were almost a full duplicate of the set operators. And the thinking was similar to how we have separate set of ops for strings. So, you know, whether we wanted to have this sort of like hard distinction, or my position was that we really want something more like this, where you're going to end up with a rational number at the end of this equation. And if this was a real, you would get a real. The point being that you don't need another set of addition operators to deal with non-integers or integers specifically.
6 is just a degenerate real.
Yeah, exactly. And so I managed to convince Perl 6, or at least Larry, that this was a case of unreasonable operator explosion. Well, I don't know if he agreed on that part, but he declared that sets are a degenerate form of bags, which creates a hierarchy of promotion. Whenever sets are mixed with bags in a set operation, the set will become a mix with the weight of 1 for each key. When mixes are mixed with bags, bags will then will become mixes, so they'll be able to hold negative weights and fractional weights. So this is similar to how we use a single set of arithmetic operators for all new numeric types. What is a bag? Right. So here we have the set of booking, and you can see here the repeating O. You know, that's not what a set is about. So here we have the actual weight, and I'm not quite sure, Liz, why this the disparity here, but anyway. Well, this is not, like, I couldn't get to have the bag on the front here instead of the course. But it doesn't, it's super unimportant.
It's because this is a Perl representation. So,
right.
Pairs are, if you specify a pair in bag new, or bag,
it's
simply taken as a pair, the pair will be the object.
Right.
You want to have the coerce.
Yeah. It's funny though. Anyway, we could discuss it later. But when I put when I use the other form, the constructor instead of the coercer. Anyway, we're getting off track. A bag is a set that keeps track of the weight of its keys. So now we know how many O's were actually in this thing. Sorry.
The rest are implied as 1.
Yes. This is an implied 1 because going through the bag coercer, each of these will be considered a pair. So that means that this operator is checking for a strict subbag when you have a bag involved, right? So when you, like, if it's just sets, then you're doing normal, absolutely, well-defined set operation. Is this a subset, a strict subset of this? So, but just to clarify what it means for bags, it's a strict subbag. A is a strict subbag of B when every key of A is present in B, and B has a higher weight for that key. For any key that's present in A has to be present in B at a higher weight.
Higher or equal.
Sorry?
Higher or equal to it? No, this is a trick. This is the trick. Sorry.
Yeah, no, no, it's a great point. And this is higher or equal. But before we would have a plus in front of this for the bags and a plus in front of the other one for behind. Anyway, I'm very happy with how everything is shaken out.
By the way, you can use the Unicode set operators.
Yes.
Not necessarily fix this one.
As well. But this being an interview, you're gonna
You have to decide whether your boss or your interviewer likes Unicode or not.
Right, and it's a shame that basically we were stalled on accepting Unicode operators specifically because nobody knows very few people know how to input them correctly, or we don't have a very good input workflow. Hopefully that'll change at some point. So, the interview. Can you tell me how this works? Yeah, so we're back to square one. And yes, the bootstrapping internals come to the rescue here. And my apologies. This this presentation went off in many different directions, so kind of getting to the edge of a cliff here. Rakudo is implemented in Rakudo and NQP. So what this means is it's not fully bootstrapped. Maybe at some point that would be amazing. But right now we use a bootstrapped language called NQP that then sort of puts stuff together in preparation for Rakudo to compile itself. So this allows anybody with some familiarity of Rakudo and you have to kind of prep yourself for all the NQP because there's a lot of it. It's just very verbose. But contrast this with, the experience of anybody who doesn't know C looking into the internals of Perl, or just a Python programmer who wants to change the internals of Python. These languages are very, implementing a dynamic language in C, to say the least. Yeah, so, if you're not at that level of insanity, then you're going to have a lot of trouble really being able to pick things apart. So, diving into Rakudo, the internals of bags and sets and all that. So NQP, it feels like a much more verbose Perl. So,
Isn't it not quite Perl 6?
well,
Not quite Rakudo.
AQR, indeed, we're going to have to change it. So I didn't know it was not quite Perl 6. I always thought it was not quite Perl. But
Not quite Perl is what they always call it.
Yeah.
There's no
It's
six.
just a restricted subset.
That's the name of
It's
it.
how Jonathan
That's
calls it.
what's called.
yeah.
It's more verbose because that simplicity complexity thing, you've simplified it in some ways so it becomes more complex in others.
Great point, Larry. Yes, that's exactly, basically it's the same language, just pushed much further on the simplicity side of the axis, which then makes the implementation more complex.
You should consider it an almost no magic version of Perl 6.
Okay.
Are we allowed to program modules?
You can. It's
But if you're kind of a masochist, you don't. The thing about not NQP is it gives you terrible error messages.
right.
You're always having to okay, we'll insert a print statement here and see what this really is, and then the print statement doesn't work, and you're trying to figure out why it can't even print anything out. There's no handy methods to stringify a lot of things, and it's just really terrible to debug on that level. Which is why we
So yeah, it's hidden behind. You have to use NQP as the pragma, and that'll make it accessible. So if you ended up needing to do some real serious performance enhancements in your own code, you could look into it. But it also opens you up to potential breaking changes. If something internally changes, the language shouldn't change, but something in the NQP layer that would never affect user space might shift underneath you.
If it's not tested in the official roast, then it's not guaranteed to stay there.
Right.
And the roast does not test NQP.
Maybe we should get a test suite for that.
Well, it has its own, but
Right.
that could be changed. That's
Right. Yeah. Oh, yeah. 10 minutes. Okay. So many lower level operations have been ported from pure Rakudo to a mixture of NQP and Rakudo. So what this means for bags and sets is that ages ago I pushed some listy forms of these things where it would take a list as an argument, and then it would do go item by item and doing introspection and seeing whether it needs to do promotion, and when obviously a much nicer solution would be to leverage our multi-method dispatch so that the pair, like, a set and a bag would end up going into, a specific subroutine that does the promotion of set to bag, and then, it's just the point being that I had some, simple, well, relatively simple code blocks that now are spanning many files and built into with some helper methods inside the Rakudo internals namespace, and which is great to put them there because it's like NQP. So anyway, that's just something to keep in mind. So the internals of Rakudo for performance reasons, we've had to kind of give up a little bit of the dream of the language implementing the language. And so when you look into the details, you're going to see a fair amount of NQP just because we want it to be fast for users. So the philosophy of torture the implementer on behalf of the user. So in terms of Quantash internals, all these types belong to the Quant hash family. Liz has done a lot of really great performance enhancements, but in practice, these have derived primarily from using NQP to access the underlying storage hashes of these, because as you learned earlier, that's the best way to implement a set, right? So what that means is you can get the NQP hash object that's being stored in the private storage hash of the set, and then you can do NQP checks at an NQP level, which means we don't have to go through, we skip several layers of indirection at that point. And then multi-method candidates, which utilize, so the VMs are meant to implement a multi-method, like a dispatch cache, basically. I guess, I don't know if it's a hard requirement that they have to, but it would be weird if they didn't. So basically, whenever, the next time that is it the optimizer that would catch that?
I think so.
So
Type specializer.
the specializer.
All sorts of.
Okay.
The specializer is what can do it during runtime, and then
Right.
the optimizer can, when you compile it, it can insert it. You don't even need to check all the other
Right.
candidates. Just go straight to that.
Right. Okay. So yeah, at runtime it would be handled by the specializer. At compile time by the optimizer. But basically, once a multi has gotten one set of arguments, it'll, whenever it gets those two types or whenever it gets a signature that matches those types, it knows exactly what code block to run. It doesn't need to go back through the tree.
I think more generally, multi-method dispatch or multiple dispatch, not always methods.
Good point.
The system knows how to optimize those.
Right.
Whereas if you do your own introspection and put your own guards in, it doesn't necessarily, it's not going to be good. Usually we think of any kind of introspection as a code spell.
Right.
These days.
In terms of internals.
Yeah.
Yeah. Yeah. So definitely, and the like I said, my original for loop, while loop version had a lot of introspection, and I was, this is my first patch to core, like one of my only patches to core, so I wasn't ready for the NQP stuff, and it fit more the kind of everything in the set operators file was slower at that point. Anyway, so okay, so basically what I'd like to do at this point, I don't know why Google forced me to have that ask a question. I don't know how to check it if you did ask any questions. So yeah, I just want to show you a a really fully pressed out version of the anagram solution. So come on now. Okay. bit. And so I'm working on actually packaging this all into a Git repo. This is a lot of details that we didn't actually go into in the talk. So one, like continuing this kind of role approach, what I would do, what I was doing to sort of test different different versions or different implementations, I created a base role that is using a stubbed method here, which obviously it's nice to have they might ask you, hey, can you memoize this? And so we can build a cache so we don't have to constantly do whatever we're going to do, whatever representation, whether it's a bag or whether it's a hash, we don't need to continuously generate that. So we just add a from cache here. We do the kind of sanitization. So here we're doing we can check for a partial and a strict, which means strict would mean that you have to have the equal number of spaces. You also have to have the equal number of all the characters have to match their case, which doesn't make for very fun anagrams, to be honest. And then strict is literally the same, except it uses the check anagram instead of check partial anagram. These could have been multis as well, but sue me. Yeah, so these are the non-strict variants do the substring here, replacing all spaces with nothing, and then calling lowercase. And then it's up to the cache to actually do something with that. So here we have the primitive. So here we have the primitive hash cache, which we can mix in. So this does the sort of like our own custom baggy thing, right? The sort of solution that you basically go to reach for if you don't have bags in your language. And so then you can mix those in. So here we have an iterative anagram introspection role, which does the base role and includes the primitive hash cache. So here we can and note that these actually don't. They're already getting the cache values into their subroutines. So the implementation details of these roles are very clean. So we have a temp. We fill in, if there's nothing, if that key doesn't exist yet in the temp, take the value from A or put 0, and then subtract the value. So the reason we can get away with this is it's a one-sided operation. We only need to check whether when you delete all the keys, all the values of all the keys from B, if you come out with a 0 at the end, when you add all those values up.
That's sort of a useless use of so then.
Oh yeah, I do that a lot. I especially when it's a return value, I just, even if it's already a bool, I'm kind of a jerk about it. So here's another iterative example. So we check, hey, that key doesn't exist, bail out early. And now we have, this is also a cool one. So basically, any infix operator can be joined with the equals sign. And this is the same as all A and B equals all A and B and. So it's up to you to decide if that readability cost is worth it to you. Once I got used to it, I found it really nice. So basically, if it survives all the way through, otherwise we bail out early and return true. Okay, 2 minutes. Okay, cool. Functional introspection. So these we don't technically need these temporary variables, right? But for me, concept that maybe I can do another talk about one time, nomic verbosity, like this just makes everything much clearer for me, having these individual temporary variables. But we do basically the same thing. If I subtract, the value from the key, I'm doing it on both sides in this case. And here's but on this side, you only need to do it for this one. So greater than or equals. And then, of course, this one, where we could push this into a separate role, but it's the only role that uses that cache strategy. So we just leave it, and there's our solution. And then you can do any variable, any container you want to put this onto. You can do so. It doesn't really make sense on anything that's not a string because you need to comb, but I'm sure there's some way to restrict that actually. Yeah, and then here's my test suite. And let's just run it real well. No, we're out. So, does anybody have any questions? Well, the propaganda. So, yeah, just to double check, let's see. Yeah, so any questions at all, or? Cool. Well, thank you for joining my talk, and please don't hesitate to get in touch with us at Booking if you're interested in hacking on some Perl, scaling some enormous systems, and dealing with an amazing customer base.